Good morning, everybody. I hope you're having a great morning so far. I need you to get out your homework. The homework was that very homemade looking worksheet that had 1 through 10 on it with the triangle, right triangle ABC, where C is always the right angle. So I need you to go ahead and get that out. What we're going to do is two things right now. We're going to very quickly go over the answers. If you have any wrong, it is really important that you understand that you are doing something wrong. And we're going to try to figure out what that is. If you got them all right, then that's good for us to see, and hopefully we're moving in the right direction. But either way, I'm not going to work all these problems. We're just going to go over the answers, and then you're going to hand it in, and so I can count that as a homework grade. Okay? So let's take a look without any further ado. Okay, number 1. Measure of angle A is 26 and side A is 15. That's what was given to you. So we can then figure that the measure of angle B is 64, the length of B is 30.8, and side C is 34.2. Number 2, the measure of angle B is 43, so therefore angle A would have to be 47. The length of A would be 65.1, the length of side B would be about 60.7. For number 3, a measure of angle B was given to be 73, so therefore measure of angle A would have to be 17. And if side B is 37, then I was able to figure out that side A is 11.3 and side C is 38.7. On number 4, you were only given the two sides. A is 21 and C is 35. You could use the Pythagorean theorem and figure out that B has to be 28. And then knowing that, angle A would be about 37 degrees using the inverse trig functions, and angle B would be about 53 degrees. Okay. For number 5, the measure of angle A is 65, which would make the measure of angle B have to be 25, and C is about 29, and so then using that information, we figure that A is about 26.3, and B is about 12.3. For number 6, the measure of angle B is 20, and A is 47, so therefore the measure of angle A is 70, length of side B is 17.1, length of side C is 50.0. For number 7, if measure of angle A is 10 and 10 degrees and B is 58, well then measure of angle B has got to be 80 degrees. I put side B, that was foolish. That's supposed to be side A right there. Side A would be about 10.2 and side C is going to be about 58.9. For number 8, measure of angle B is 66. Side B is 41. So therefore, measure of angle A has got to be 24 degrees. Side A has got to be 18.3. Side C has got to be about 44.9. Okay. And last two, you're given just two sides of the right triangle. So you use the Pythagorean theorem to figure out the third side. So B would have to be about 32.9. And then using those and some inverse trig functions, I can figure out that the measure of angle A is about 27. Measure of angle B is about 63 degrees. For number 10, if you use Pythagorean theorem to figure out that C is about 24.2, measure of angle A is about 38 degrees, measure of angle B is about 52 degrees. Okay, so we came in on Tuesday and we reviewed for the entire period, but I want to do a real fast review and just kind of take a look at the things we talked about. First of all, we said, okay, so I'm sorry, you can pause the video right now so we can turn in the homework and then we'll get back to talking about what we need to talk about. Okay, so hopefully the homework's all turned in. All right, so here's what we're doing. We're going to talk about trig. And remember, we said that trig is all about functions. And functions ultimately are all about this input-output relationship. And so then we kind of talked about and even labeled what the input of every trig function was, and it was the measure of an angle. Okay? And the output was always the ratio, or fraction, is really kind of how we want to think about it, of two sides of a right triangle, okay? Two sides of a right triangle. And so we always want to think about that. So every time we have a trig function, no matter what trig function it is, it should be immediately followed with the measure of an angle because that is the input. And then there's going to be an equal sign. And on the output, there will always be a fraction. And that fraction will be two sides of a right triangle. So for instance, if I have a triangle right here and I said, hey, this is a right triangle and this angle right here is about 39 degrees, and I knew that this side was 17 and this side over here is going to be, 13, and this side I'm unsure about. We'll call that X, okay? Well, what I could do is I could say, well, hang on, let me go ahead and I'm going to get rid of the 13. We'll just say we know just the one side. We'll say that this, we know that that side's 17. And so I could look at this and say, well, I know that the sine, S-I-N is sine, not sin, of 39 degrees. Notice, okay, there is my input, okay? Always got to have the measure of that angle, is equal to, and this is where I'm going to do a fraction. The sine, okay, if we think about toa, sine meant opposite over hypotenuse. So that's going to be y over 17. Okay, and then we can solve from there. But we always have to start with this, where we should be able to easily see the input and see the output. Input's the measure of an angle, output's a fraction of two sides of a right triangle. And then I would be able to do cosine. Say cosine of 39 degrees, and cosine is CAH, so that's cosine is adjacent over hypotenuse. So cosine of 39, there's my input, is equal to adjacent x over hypotenuse, 17. And we should be able to solve those. And for both of those, I'd multiply this side by 17 and multiply this side by 17, algebraically speaking, and these would cancel out. And then I'm left with y is equal to 17 times the sine of 39 degrees. And that's something I have to plug into a calculator. I don't just know that. I have to look and go, okay, that one I gotta have a calculator for. Okay, and same thing with this other side. Over here, I go, okay, I can multiply this by 17 and this by 17. These cancel out, and that gives me that x is equal to 17 times the cosine of 39 degrees. And again, okay, got to plug that into a calculator at that point, and I'd be able to figure out what this side x and what this side y is on that triangle. Okay, and so that's all the basic stuff we need to know. We need to know that trig is about functions. Functions are input and output. The input is always the measure of an angle. The output's always a fraction of two sides of a right triangle, okay? And then if there's nothing else you remember, please remember SOHCAHTOA. And it's a pretty easy thing to remember, okay? So here's what I want to do. I want to work through two quick examples right here, so that way you feel pretty comfortable, all right? I don't need you to write these down, but you're going to do 3 for me in just a second. So if you're a little unsure, I know there was a couple students at different times who are going, man, I still don't know where to begin. If that's you, then yes, 100% you should be writing this down. You don't need to draw the picture. Picture's on the board, but I need you to write this down. Okay, so let's take a look. On this first one, I'm going to, and this is just like the example I showed a second ago, I'm going to say the sine of 32 degrees is equal to x over 41. And if you're wondering where I'm getting that, I'm going, okay, SOHCAHTOA. Okay, so sine is opposite over hypotenuse. So opposite over hypotenuse. So that's where I get the x over 41. Okay, I'm going to go ahead and multiply both sides by 41. And when I do that, these cancel out, and I get that x is equal to 41 times the sine of 32 degrees. And so with that, I can just plug that into a calculator and say 41 times the sine of 32 degrees, and I get about 21.7. I'm just going to round to the nearest tenth, 21.7, about. Okay? And then if I say, well, now let's figure out y. Well, y is adjacent to this 32 degrees, so I'm going to use cosine because that's adjacent in hypotenuse. So I'm going to say, well, I know that the cosine of 32 degrees is equal to adjacent, that's y, over hypotenuse, 41. So I'm going to multiply both sides by 41. And these cancel out right here. And I get y is equal to 41 times the cosine of 32 degrees. And so then again, grab my calculator, 41 times the cosine of 32 degrees, and I get that's about 34.8. Again, I'm going to round to the nearest tenth, 34.8. Okay. All right. And so this is really simple stuff. All right. This next one, though, notice I have two sides, but what I don't have any angles. Now, of course, I know that this is a right angle, but I don't know what these other two angles are. And so for these, you had to use what's called an inverse trig function. But either way, you still use SOHCAHTOA to write your initial statement, okay? So I don't, it depends on what perspective. If I'm looking at angle X then I have got the adjacent side and I have the hypotenuse. So that's going to make me think about cosine, okay? So I'm going to say the cosine of x, there's my input, there's my angle. I don't know what it is, but it's still got to be there, is equal to a fraction. What's the fraction? Adjacent over hypotenuse. Okay. Now, I know a lot of people are going to start going, well, and then at this point, I got to multiply both sides by 21, and that would be completely wrong. So let's not go there and do all that. Okay. What we've got to do instead is we're trying to get this x by itself right here. We're trying to isolate that x. And so we said that anything you do in math, you can undo. And that's true with trig functions. So I have to use what's called an inverse function. Cosine to the -1 is an inverse trig function, okay? Looks like that. Cosine to the -1 is an inverse trig function. So I'm going to say the inverse of cosine. I'm going to do the inverse of both sides. Inverse cosine of both sides. And look what happens when I do that. See, the inverse cosine and cosine cancel each other out, leaving only x on that side. So I get that x is equal to the inverse cosine of 16 over 21. Now, if you don't know where the inverse cosine is, you just have to hit the blue button second and then hit cosine because it's right above cosine. And so I type that in. I hit second and then cosine, and I'm going to see this exact same thing. Whoops, erasing things. I'm going to see this exact same thing, just like this. It's going to have that little -1 too. Okay, so inverse cosine of 16 divided by 21, and then I'm going to close the parentheses and hit enter, and I get 40.3675, something ugly. So I don't want to write with a pen. And so I get, if I round to the nearest degree, I get that x is about 40 degrees. Okay, and if x is about 40 degrees, so if this is about 40 degrees, then this one would have to be about 50. Because the three angles have to total 90. So I got 180, or I'm sorry, the three angles have to total 180. So I've got 180 minus the 90 minus the 40, okay? Well, 90 and 40 come together, make 130. So I say, 180 minus 130 gives me 50 left over. And that's where that comes from, okay? 50 degrees. And so at this point, I would know that y is about 50 degrees. Okay. Now I could also double check that. I could go ahead and use, an inverse trig function and kind of look at that. So I'm going to set this, that didn't set over there. I'm going to, the amazing growing trig. Okay. What I'm going to do is I'm going to say, well, I could say if I'm looking at y, I could say the sine of y is equal to the opposite over the hypotenuse. SOH, sine, S-O-H. Sine is opposite over hypotenuse. So I could take the inverse sine of both sides. These cancel each other out, and I get that y is equal to the inverse sine of 16 over 21. And then I plug that in my calculator, hit second, and then sine 16 divided by 21, and I get, sure enough, 49.63. So I'd go, man, that rounds up, and y ends up being about 50 degrees. And that's what I thought it was, okay? All right, so I did 2 for you, so you should be at least a little bit reviewed. All right, now time for you to do these 3. Notice there are 3 variables in each situation, okay? There are 3 variables in each situation. What I want you to do is find the value of all 3 variables. So we can pause the video right here. I'm guessing for everybody to do all 3 of these, it's going to take somewhere around 10 minutes, maybe a little bit less. But when you guys are ready, then we'll go through them. Okay, hopefully you feel confident about your answers and you like what you have. Okay, the first one's really simple, and the second one's really simple because the first 2 are just like the ones I just showed you right here. Okay, the third one is a little bit different, but it's still not hard. It just uses a little bit different step in pre-algebra. So I'm going to go through these really quickly because you probably already have the answers. So let's take a look at this. For the first one, I'm going to say, well, I know the sine of 62 degrees is equal to a over 23. Multiply both sides by 23. Okay, so then you get a is equal to 23 times the sine of 62 degrees. So I say 23 times the sine of 62 degrees. And I get, well, that's about 20.3. I'm going to round to the nearest tenth for the sides, 20.3. Okay, for b, I'm going to say the cosine of 62 degrees is equal to adjacent, which is b, over 23. Multiply both sides by 23. And I get that b must be equal to 23 times the cosine of 62. So I plug that in my calculator. Let's say 23 times the cosine of 62. And I get that's about 10.8. And the other thing that you should have gotten is C. That's really easy. That has to be 28 degrees. Because if this is 62, then this has to be 28. Because those two angles always add up to 90. All right, let's go for this next one. Okay, for here, the first thing I'm going to do is I'm going to use the Pythagorean theorem to figure out what D is. So that would mean I can say 13 squared plus D squared would have to be equal to 17 squared. So that's going to be 169 plus D squared is equal to, what, 289, I think is 17 squared. So then I subtract those, and I get that D squared has got to equal 120. And so therefore D equals the square root of 120. Now that doesn't have a nice, clean, even square root, but I'll go ahead and get an approximate answer. And that ends up being about 10.9541. So the 5 would round the 9 up, and that would actually become about 11. So I say D is about 11. Okay? Now we got to find the angles. And so for that, I got to use those inverse trig functions. Okay? And so I might say, well, the sine of y, if I put myself in the perspective of y, sine is opposite over hypotenuse. And so the sine of y is equal to 13 over 17. Take the inverse sine of both sides. These cancel each other out. I get y is equal to the inverse sine of 13 over 17. I'm going to go ahead and type that in. Inverse sine of 13 divided by 17. And I get that that's about 49.88. So it'll be about 50 degrees. Okay? And so if that's 50 degrees, then this has to be 40 degrees. Now, I'm sorry that happened to come out the exact same way as last time that I've got 50 and 40 again. That was just by happenstance. It was just lucky. That was not on purpose. That's not how it's going to work out every time. Okay, so I've got all the information there. Now let's do this last one. Now this last one's got a little bit of something different. If I try to figure out G, and I say, well, the cosine of 51 degrees is equal to the adjacent over the hypotenuse, then I would look at this, and a lot of people, when they're not thinking, they just think, I'm going to multiply both sides by 31. But the problem is that doesn't work, because you don't need to multiply by 31. I've already got a 31. What I have to do is I always have to multiply by what's in the denominator. And the 31 is not in the denominator. So what I got to do is I got to look and say, I got to multiply this side by G. See, over here, I multiplied by what's in the denominator. What's in the denominator? So this side, I got to multiply by what's in the denominator. So I'm going to multiply this side by G. These cancel out, and I get G times the cosine of 51 degrees is equal to 31. Now, that's not a very good answer, because I don't want G times the cosine of 51. So I have to divide both sides by cosine 51. Okay? And when I do that, then these cancel out, and I'm left with G is equal to 31 over the cosine of 51 degrees. Okay? And that I can plug into my calculator. So I say 31 divided by the cosine of 51 degrees. And when I do that, I get about 49.25. So that's going to be about 49.3. So G is about 49.3, okay? So that's what this side is right here. Now, clearly, E has got to be 39, because if this is 51, this has got to be 39. The two of those have to add up to be 90. And now I could use sine to figure out F, okay? And I could say, well, let's see here. No, I don't really want to use sine. I want to use tangent, because this is the side I have. So I've got opposite and adjacent. And so I'm going to say the tangent of 51 degrees is equal to opposite, that's F, over adjacent, 31. Now, again, I got to multiply by what's in the bottom of the fraction. And in this case, 31 is in the bottom of the fraction. So those cancel out, and I get F is equal to 31 times the tangent of 51 degrees. And so I plug that into my calculator and say 31 times the tangent of 51 degrees. And I get that that's about 38.281. So that's about 38.3. Okay, so there's F. There's G, and there's E. Okay, hopefully you have all of those. So now what we're going to do is I'm going to have you work on a brief worksheet that has 9 problems. On each problem, you're actually only looking for one unknown. So these should be pretty simple and pretty quick. I think each problem should only take you about a minute or two. So this should really only be about 10 or 15 minutes worth of work at tops. All right, and then we will take a look at the answers of those and try to go over them. All right, good luck.